We are from Group 1. We are going to show a demo of our project on Brainet Android application. These are our team members. Our application identifies a user using his brainwave signal with the help of a decision tree. Mobile application developed chooses fog or remote server based on network connectivity, battery level, and execution time. When choose the best option is selected. User has an option to select fog or remote server from the application. Our data set is taken from this site. The complete data set, as you can see, has brainwave signals for close to 109 users. In each of the user data set, the brain signals are collected for a set of 14 tasks. As you can see, these are the 14 tasks based on the 4 tests which are present here. And as you go into the EDF file, this is the raw form of the brainwave signal. This is passed in MATLAB using a EDF read function. And we concatenate all the EDF file data into a single matrix as shown in the code. This is the code which you use to parse all the EDF files. So this folder contains all the EDF files in the dataset. And we are trying to concatenate all the EDF files by parsing using the EDF read function. And apparently, with 109 users, the entire dataset came up to close to 106 GB. So thus, we selected 10 users for application. The dataset now comes to close to 500 MB. Now, all the data is present in this final dataset.csv. Now, after the data is processed, this dataset is now trained into a decision tree model that uses Gaussian naive Bayes for its classification. The trained model is serialized into a PKL file. The PKL file is used for prediction when a testing set is presented to it. It was found that the accuracy of this model was to be 80%. This PKL file and the trained model are both deployed into the fog and remote server. The fog and remote server code can be seen here. This fog and remote server accepts a brainwave signal sent from Android app and returns user the label that was classified by the trained decision tree model. As you can see, it uses the CLF predict, it gets the input, and it returns the result. So, as of now, we have data processing completed, classifier trained, and deployed in both fog and remote server. Coming to our Android application, we have two activities. One, having the user an option to select classification using fog server, remote server, or the best of the two automatically. The other activity displays the label of the user that was classified by the model, battery level, and execution time of the pipeline. When the user selects any of the options, a random brainwave signal out of the 10 users is selected and is transmitted to the user deployed on the selected server. So this is the code of our project. We are using this function to calculate the battery levels, and we are putting the battery levels. And this is the function which is used for sending the brainwave signal to the fog server. We are using the test data, we are passing the input, and after passing the input we have 10 users, and we use a random function to get a random user out of the 10 users. So this is a local IP which is deployed. So this fog server is deployed in the same mobile subnetwork as the mobile phone is. So this is an IP where the fog server is deployed to, and it is sending the test sample to this IP, and it's getting the result and it's displaying along with the battery level and the execution time taken. The send remote data activity is pretty much the same, except that it has a remote server. We have deployed the application remote server in AWS, and we can see a small glimpse of the AWS server and the local server running. This a snapshot of the local server which is running. It's just a server which is in the same subnet as the mobile phone is. And this is a snapshot of the AWS. If you can see the public DNS, it has a similar link which is showed earlier in the code. And now let's go forward and run a demo of the application. So this is the application. You have three options. You can either get it classified with Fox server or remote server or choose the best. So we'll go one by one. Right now we have the Wi-Fi signal. So the Fox server is going to be in the same network. Just clicking the Fox server. A random user is selected and it is sent to the Fox server, and it seems that the user is 3. The execution time is the time taken for the whole computation to take place and the result to come. So the execution time is 153 milliseconds and the battery level is 59%. Similarly, for remote server, as you can see, the user is 1 and the execution time is 202 milliseconds and the battery level is 59%. The only difference is that the Fox server is in the same network and the remote server is deployed in AWS. Now, when I click choose the best, it chooses the best servers based on the presence of the Wi-Fi signal. If the Wi-Fi signal, due to network latency and the response time, it's always going to be faster in the Fox server, and it usually selects the Fox server as default when the Wi-Fi is switched on. So as you can see, Fox server is chosen. And now when we switch off the net or when the battery is high, I'll just show you the demo. The remote server is chosen. So on the basis of the presence of Wi-Fi, the battery level, and the execution time, an appropriate server is chosen. Thank you.